Standing next to the hull of a modern armored fighting vehicle is an experience that fundamentally changes your perception of scale and violence, and nowhere is this more apparent than when you approach the latest iteration of a machine that was supposed to be retired decades ago. The M2 Bradley has been the workhorse of the American Mechanized Infantry for 40 years, a vehicle that has survived political scandals, budget cuts, and the brutal reality of combat in multiple theaters to emerge as perhaps the most combat-proven fighting vehicle in history. But just when you thought the story was over and the replacement was imminent, the United States Army decided to double down yet again, pouring over $600 million into a platform that critics have been trying to kill since the 1980s. We are looking at the M2A4E1 Echo One Bradley, a designation that sounds like a mouthful of alphabet soup but represents a critical pivot in armored warfare philosophy. This is not just a fresh coat of paint and a new radio. This is a radical attempt to solve a physics problem that has plagued designers for half a century. How do you stop a rocket-propelled grenade that travels faster than sound without making the vehicle so heavy it sinks into the earth? The answer lies in a strange Israeli system bolted to the turret, a suspension overhaul that cost a fortune, and a refusal to let the old warhorse die. There is a central conflict at the heart of this machine, a paradox that we need to unravel to understand why this specific variant exists right now. For years, the narrative has been that the Bradley is too old, too tall, and too vulnerable to survive on a modern battlefield, saturated with drones and top attack missiles. We were told that the next-generation combat vehicle was just around the corner, ready to sweep the slate clean with futuristic designs and unmanned turrets. Yet, when the dust settled and the strategic realities of Eastern Europe became clear, the Army did not rush the futuristic prototypes to the front lines. Instead, they took the existing M2A4E1, a vehicle already pushed to its absolute mechanical limits, and grafted on a system called Iron Fist. The result is a vehicle that challenges every assumption we have about obsolescence. The M2A4E1 Echo One is a testament to the idea that sometimes the best weapon isn't the newest one, but the one you can modify to survive the specific hell of the current moment. This analysis is going to take you inside the hull to understand the engineering trade-offs, the suspension geometry that keeps 40 tons floating over mud, and the terrifying calculus of active protection systems. If detailed technical breakdowns of military design and strategy interest you, subscribe. I have got more of these coming because the engineering history of these machines is often far more fascinating than the simplified narratives we see on the news. To understand the Echo One, we have to understand the crisis that birthed the standard M2A4E1. By the time the Iraq War ended, the previous version, the M2A3, had become morbidly obese in mechanical terms. The original Bradley back in the early 80s weighed roughly 25 tons, which allowed it to be nimble, amphibious, and relatively easy to transport. But over 30 years of combat, the Army kept adding things. Reactive armor tiles to stop shaped charges, heavier belly armor to stop improvised explosive devices, more ammunition, more electronics, and more water. By 2010, the vehicle was pushing 35 to 40 tons, but it was still riding on a suspension and powertrain designed for a much lighter machine. The result was a logistical nightmare where torsion bars were snapping, transmissions were grinding themselves to dust, and the vehicle sat so low on its suspension that it lost the ground clearance necessary to survive mine blasts. The Bradley had lost its mobility, which is the primary survival mechanism for any infantry fighting vehicle. You cannot fight if you cannot move, and the M2A3 was slowly becoming a pillbox rather than a cavalry vehicle. The M2A4 program was essentially a massive reset button for the automotive components of the vehicle, designed to restore the automotive performance to the original design specifications, despite the increased weight. The engineers at BAE Systems had to rip out the guts of the drivetrain and install a new Cummins VTA9 03 Echo T675 horsepower engine. This 8-cylinder diesel engine is a beast, providing the raw torque needed to push 40 tons through deep mud and sand. But power is nothing without a way to transmit it to the tracks, so they paired it with an HMPT 803 Echo C hydraulic transmission. This is not like the transmission in your car. It is a complex hydromechanical system that allows for infinite gear ratios and pivot steering, letting the Bradley spin in place like a top. The most critical upgrade, however, was the suspension. They installed heavy-duty torsion bars and high-performance shock absorbers that lifted the vehicle back up, restoring its ground clearance from a dangerously low 15 inches back up to 18 inches. This might sound like a minor detail, but in the world of blast deflection, 3 inches of air gap can be the difference between a crew going home with concussions or not going home at all. This restoration of automotive power was successful, and the M2A4E1 began fielding to units, giving the Army a vehicle that could actually handle its own armor weight. But as soon as they solved the mobility problem, a new threat matrix emerged that steel and ceramic armor simply could not handle. We entered the era of the proliferation of advanced anti-tank guided missiles and loitering munitions. In conflicts from Syria to Nagorno-Karabakh to Ukraine, it became evident that you could not put enough passive armor on a vehicle to stop a modern tandem charge warhead without making the vehicle so heavy it would collapse bridges. A tandem charge works by firing a small precursor explosive to trigger the vehicle's reactive armor, blowing a hole in the defense, and then firing a second main charge through that hole to penetrate the main hull. To stop this with physical armor, you would need feet of steel or composite, which is impossible for a vehicle that needs to keep up with tanks. The designers were trapped in a corner. They had just fixed the suspension to handle the current weight, but they couldn't add any more weight to stop the new missiles. The Echo One variant is the answer to this deadlock. The designation Echo One specifically refers to the integration of the Iron Fist light decoupled active protection system developed by BAE Systems. This is where the science fiction begins to merge with gritty reality. An active protection system, or APS, is essentially a miniature missile defense shield for a single tank. It consists of small radar panels mounted around the turret that constantly scan the environment for incoming high-velocity threats. When a rocket-propelled grenade or an anti-tank guided missile is detected, the computer calculates its trajectory in milliseconds. If the threat is determined to be on a collision course with the vehicle, the system rotates a small launcher in the direction of the threat and fires an interceptor munition. This interceptor is not a bullet. It is a small explosive device that detonates near the incoming missile. The shockwave and fragmentation from the interceptor destroy the missile's warhead or knock it off course before it can touch the vehicle's skin. The decoupled part of the name is crucial here because it means the launchers are separate modular units that can be bolted onto the turret without requiring a complete redesign of the turret's internal structure. However, integrating Iron Fist was a nightmare that nearly killed the program multiple times. The first issue was power consumption. The radars and computers for the APS require a tremendous amount of electricity, far more than the original alternator of the Bradley could provide. The M2A4E1 upgrade had included a new intelligent power management system, but even that was pushed to the limit. The second and more difficult problem was the aerodynamics and balance of the interceptor itself. During early testing, the system struggled with the complex clutter of a battlefield, differentiating between a bird, a friendly drone, and an incoming missile is an incredibly difficult algorithmic challenge. Furthermore, the interceptor creates an explosion very close to the vehicle. If you have infantry troops dismounted and walking next to the Bradley, which is literally the job of an infantry fighting vehicle, the active protection system could inadvertently kill the very soldiers the vehicle is supposed to support. This necessitated the development of complex safety protocols and directional blast capabilities to minimize collateral damage, a feature that distinguishes modern Western APS from older, cruder Soviet designs like Drozd. The M2A4E1 Echo One, therefore, represents the successful marriage of the revitalized automotive chassis with this high-tech shield. But this brings us to the price of the solution, a concept every engineer knows well. By adding the iron fist, the weight crept back up. The sensors added drag and snag points. The power draw meant that the engine had to work harder, increasing thermal signature and fuel consumption. It is a constant game of cat and mouse. You fix the suspension to carry more armor. Then you realize armor isn't enough, so you add a heavy electronic system, which stresses the suspension and power grid again. The Echo One is pushing the absolute theoretical limits of what the original 1970s Bradley chassis design can accommodate. We are looking at a vehicle that is stuffed to the gills with cabling, hydraulics, and ammunition, leaving very little room for future expansion. It is a dense brick of technology, and while it is undeniably capable, one has to wonder how much more can be squeezed out of this airframe before the laws of physics simply say, no more. Let us move inside the turret to talk about the teeth of this beast, because all the protection in the world is useless if you cannot fight back. The primary armament remains the M2A4E1 Bushmaster, a 25mm chain gun that is arguably one of the most reliable weapons ever made. Unlike a gas-operated machine gun that relies on the explosion of the round to cycle the bolt, a chain gun uses an electric motor to cycle the action via a chain loop. This means that if a round is a dud, the gun doesn't jam. The motor simply cycles the dead round out and loads the next one. It provides a level of reliability that is absolutely essential in the chaos of close combat. The gunner can select between two types of ammunition on the fly: the M792 high-explosive incendiary, with tracer for soft targets like infantry and trucks, and the M919 armor-piercing fin-stabilized discarding sabot with tracer. The armor-piercing round is particularly terrifying. It uses a depleted uranium penetrator that sharpens as it passes through armor, creating a pyrophoric effect. Essentially, the dust from the penetrator catches fire upon impact, incinerating everything inside the target vehicle. The fire control system on the A4E1 Echo One is where the lethality takes a quantum leap over the older Desert Storm-era Bradleys. The vehicle is equipped with the improved Bradley Acquisition Subsystem, or IBAS. This includes a second-generation forward-looking infrared sensor. To explain the difference between first and second-gen FLIR, imagine looking through a screen door versus looking through a high-definition window. In the Gulf War, gunners could see heat blobs, but often couldn't tell if it was a truck or a tank at 3 kilometers. With the second-gen sensors on the Echo One, a gunner can identify specific features of a target, such as whether a man is holding a rifle or a shovel, from kilometers away in total darkness or through smoke. The system also includes an eye-safe laser rangefinder and automatic target tracking. The gunner simply puts the crosshairs on the target, lasers it, and the computer calculates the lead, elevation, and windage. The turret rotates automatically to keep the gun on target even as the Bradley bounces over rough terrain. It turns a complex ballistics problem into a point-and-shoot interface. However, the gun is only half the equation. The hammer of the Bradley is the TOW missile launcher box on the side of the turret. TOW stands for Tube-Launched, Optically Tracked, Wire-Guided. The A4E1 carries the TOW-2 Bravo Arrow missiles. Unlike the gun, which requires a direct line of sight and kinetic energy, the TOW missile allows the Bradley to destroy main battle tanks from nearly 4 kilometers away. The Bravo variant is a top attack missile. It flies slightly above the line of sight and detects the large metal mass of a tank as it passes over it. It then detonates 2 downward-facing shaped charges, punching through the thin roof armor of the tank. This capability makes the Bradley a tank destroyer as much as it is an infantry carrier. The Echo One upgrade ensures that the software interfaces for the missile launcher are integrated with the new commander's independent viewer, allowing for hunter-killer operations. The commander can scan for a new target while the gunner is engaging the first one. Once the gunner is finished, the commander hits a button. The turret swings to the new target, and the engagement continues seamlessly. Now we must address the operational reality of living and fighting inside this machine. It is easy to look at the spec sheet and see 9 passengers, but the reality is far more cramped and chaotic. The driver sits in the front left hull, isolated from the rest of the crew, staring through a bank of periscopes or a thermal display. The engine roar is deafening, a constant thrum that vibrates through your bones. In the turret, the commander and gunner are squeezed into a basket that rotates, surrounded by the breech of the cannon, the missile electronics, and the radio racks. But the real story is in the back. The infantry squad compartment in the M2A4E1 has been reconfigured for better mine protection, with seats suspended from the ceiling rather than bolted to the floor. This decouples the soldiers from the shock of a mine blast under the hull. However, the space is incredibly tight. With full body armor, weapons, and day packs, 6 soldiers are packed in like sardines. The ride is rough. Despite the new suspension, cross-country travel at 40 kilometers per hour feels like being inside a tumbling dryer filled with rocks. The experience of the crew in Ukraine, operating the older M2A4E1 ODS variants, gives us a window into why the Echo One upgrades are so vital. Ukrainian crews have reported that the 25mm Bushmaster is devastatingly effective against Russian BTRs and BMPs, often disabling them before they can return fire. The optics have allowed them to spot ambushes at night long before the enemy knows they are there, but they have also highlighted the vulnerability to drones. The Iron Fist APS on the Echo One is the direct answer to the first-person view drone threat. While Iron Fist is primarily designed for anti-tank missiles, the radar sensitivity allows it to detect some classes of loitering munitions. This provides a psychological layer of security for the crew, knowing they are not helpless against a threat they cannot even see. However, the maintenance burden is real. The M2A4E1 is a maintenance hog. The tracks require constant tensioning. The hydraulic lines for the ramp and turret are prone to leaks if not checked daily. And the sensitive electronics of the new fire control system hate moisture and dust. Knowing what you now know about its performance in the field and the massive complexity of the Iron Fist system, do you think the design trade-offs were worth it compared to building a new vehicle from scratch? Share your thoughts below, because the debate between upgrading the old versus buying the new is one of the most heated in military procurement. Let us compare the M2A4E1 Echo One to its contemporaries to see where it truly stands. The most direct comparison is the German Puma. The Puma is a marvel of modern engineering, unmanned turret, modular armor, and extreme mobility. On paper, the Puma is superior. It offers better protection levels for the weight and has a 30mm cannon. However, the Puma has been plagued by reliability issues and an astronomical price tag. It is a Ferrari where the Bradley is a Ford F-150. The Bradley might be older, but the logistics chain is established. We know how to fix it. We have thousands of spare engines. The Echo One upgrade leverages this institutional knowledge. Another competitor is the Swedish CV90. The CV90 is an excellent platform, highly mobile and versatile, often carrying a 40mm Bofors gun. But the CV90 generally lacks the heavy anti-tank punch of the TOW missiles integrated so seamlessly into the Bradley. The Bradley remains one of the few IFVs that can confidently engage a main battle tank and win. Then there is the Russian BMP-3. The BMP-3 is lighter, faster, and carries a 100mm low-pressure gun alongside a 30mm autocannon. It sounds impressive, but the protection is abysmal. The BMP-3 is essentially a swimming bomb, with fuel tanks stored in the rear doors and ammunition scattered throughout the hull. When a Bradley hits a BMP with a 25mm depleted uranium round, the BMP usually detonates catastrophically. The Bradley, by contrast, was designed with survivability as a priority after the lessons of the Vietnam War. The ammunition is stored in separated compartments with blowout panels where possible. The sheer size of the Bradley, often criticized as a tall barn, actually helps in survivability. It creates internal volume so that if a penetrator does enter, it is less likely to hit a critical system or a crew member compared to the cramped confines of Soviet-designed vehicles. The introduction of the Echo One also signals a shift in how the U.S. Army views the timeline of the next-generation combat vehicle, specifically the XM-30 Mechanized Infantry Combat Vehicle program. The XM-30 is intended to eventually replace the Bradley. It will feature a hybrid electric drive, a 50mm cannon, and an unmanned turret. But the XM-30 is still years away from full-scale production and fielding. The decision to fund the M2A4E1 Echo One is a tacit admission that the Bradley will need to hold the line until at least 2030, and possibly longer. The Pentagon War's narrative that painted the Bradley as a failure has been thoroughly debunked by history. The vehicle that Colonel James Burton famously derided as a death trap proved to be the most effective armored vehicle of the Gulf War, destroying more Iraqi armored vehicles than the Abrams tanks did. The Echo One builds on this legacy of lethality. The engineering challenges of the Echo One extend to the software architecture. Modern warfare is network-centric. The Bradley is no longer just a fighting vehicle. It is a node in a massive digital network. The Alpha 4 upgrade included the installation of the Force 21 Battle Command Brigade and Below System, or FBCB2, which has evolved into the Joint Battle Command Platform. This system displays a digital map showing the location of all friendly units in real time, known as Blue Force tracking. The commander can send text messages, map overlays, and enemy locations to other tanks and helicopters instantly. The integration of Iron Fist into this network is the next step. In theory, if an Iron Fist sensor on one Bradley detects an incoming missile launch from a specific coordinate, that data could be instantly shared with the artillery battery miles behind the line, bringing down counterfire on the enemy anti-tank team within seconds. This sensor-to-shooter loop is the holy grail of modern combat, and the Echo One is the first Bradley variant fully capable of participating in it at this level. But we must return to the dirt and the mud. All this technology adds weight, and weight dictates where you can go. The M2A4E1 Echo One tips the scales at nearly 40 tons fully combat loaded. This limits its ability to cross certain smaller bridges in Eastern Europe and the Pacific. It increases the risk of bogging down in soft soil. The wider tracks help distribute the pressure, but physics is unforgiving. The logistics tail required to keep a brigade of these machines moving is immense. Fuel tankers must work overtime as the VTA-903 engine is thirsty, especially when idling to power the electronics. The Army is paying a price for this capability in terms of strategic mobility. It is harder to fly these vehicles into a conflict zone than it was with the original 25-ton version. You can fit fewer of them on a C-17 Globemaster transport plane. This means that in a rapid deployment scenario, the heavy armor takes longer to arrive. Yet, despite the weight, the cost, and the age, the M2A4E1 Echo One is arguably the most well-rounded infantry fighting vehicle in the world today. It hits the sweet spot of the Iron Triangle: firepower, mobility, and protection. It has enough armor to stop anything short of a main battle tank round or a heavy anti-tank missile, thanks to Iron Fist. It has the firepower to kill anything on the battlefield, including tanks, and it has the mobility to keep up with the Abrams. The decision to upgrade was not just about saving money, it was about risk management. Developing a new vehicle takes 15 years and is fraught with technical peril. Upgrading the Bradley is a known quantity. The engineers knew the hull geometry, they knew the weak points. The Echo One is the result of 4 decades of lessons learned, written in blood and oil. Consider the human element of the gunnery skills required. A master gunner on a Bradley is a highly trained specialist. They have to understand the ballistics of the 25mm round, the flight path of the TOW missile, and the logic of the engagement process. With the Echo One, they now also have to manage the status of the active protection system. They have to know when to turn it off, for example, when friendly infantry is too close, and when to enable it. The cognitive load on the crew is higher than ever. The screens inside the turret provide a wealth of information, but it can be overwhelming. The Army has had to update its training simulators to account for the new capabilities, teaching crews how to trust the automated systems while maintaining manual override skills. The legacy of the Bradley M2A4E1 Echo One will likely be that of the ultimate stopgap. It serves as the bridge between the Cold War era of mechanical warfare and the coming age of robotic and hybrid electric warfare. It proves that a sound fundamental design can be adapted far beyond its original scope. When the designers in the 1970s drew the first sketches of the XM2, they never imagined it would be carrying a radar-guided missile defense system or networked digital maps. They designed a box to carry troops and shoot back. That box has evolved into a Predator. As we look at the future of the U.S. Army's armored formations, the Bradley remains the backbone. The Abrams gets the glory, but the Bradley does the work. It clears the trenches, suppresses the infantry, and watches the flanks. The Echo One ensures that it can continue to do this work in an environment where the threats have become smaller, faster, and more lethal. It is a loud, heavy, expensive, and fuel-guzzling machine, but when you are pinned down under fire, the sound of that 25mm chain gun opening up is the most beautiful sound in the world. The M2A4E1 Echo One is not perfect, but it is a survivor, and in war, survival is the only metric that truly counts. If you found this analysis useful, a like helps more people discover these deep dives. Thanks for watching.